Okay guys, today we are working with polar equations. So we are going to be converting rectangular to polar equations and then polar equations to rectangular. So as you can see above here, I'm reminding you to go back and forth where x is r times cosine and y is r times sine. And then we have r squared equals x squared plus y squared. Of course, our tangent and theta will work later on. So what we're going to do is, you see that this is in our Cartesian. So this is x and y. And we need to make it in and solve for r to see where it would land for that. So first thing I'm going to do is substitute in my x and y's, because I can substitute with the r cosine and the r sine. So let's do that now. I get r cosine theta, oops, I'll just put that there, minus 3 squared plus r sine theta squared equals 9. Okay. Now again, the goal in the end of this really is to solve for r and see what we can conclude from there. So the first thing I want to do here on this side is FOIL this and extend this squared out. So if we FOIL, we get r cosine theta squared minus 6r cosine theta minus 3 plus, I'm going to keep this as r sine theta squared so you can see my next step. Now when I expand this square out, it goes to both of these terms. So I'm going to write over here so I give myself enough room. I get r squared cosine squared theta minus 6r cosine theta. I'm also, oh, I forgot, this is not 3 right here, guys, this is 9. I also noticed that these two 9s cancel, okay? So I'm actually going to keep that as 0. So r squared sine squared theta. I don't mind making these little mistakes because hopefully it shows you need to actually watch your steps, because that little math. So right here, guys, the reason why this was 9 is because I forgot to square that 3 when I FOILed, and then these two 9s cancel, so it's 0. Alright, remember the goal is in the long run to get r by itself. Well, let's see what I can do here. I'm going to rearrange this and put these two closer together, okay, because there is a connection between cosine squared and sine squared. And if you remember that identity, when you add those two together, it gives you the value of 1. So let me show you that. So we get r squared cosine squared theta plus r squared sine squared theta minus 6r cosine theta equals 0. If you see, I can pull out this r squared, leaving with a cosine squared theta plus sine squared theta, and then of course I still have this minus 6r cosine theta equals 0. So as you can see, this value right here is the value of 1. So we get r squared minus 6r cosine theta equals 0. Alright, so now let's factor out an r. So we have r times r minus 6 cosine theta equals 0. We can then split this up. That means r equals 0, which doesn't really help us because r equals 0 is just a point. It's not an equation, right? So actually, we can get rid of that and kind of ignore that because that's a point. That's not an equation. And then I can see that this then, to solve for r, would be r equals 6 cosine theta. And there is our polar equation. So wherever r equals 6 cosine theta, then we know we have our equation, or our graph. Alright, B, let's do the same thing. Let's substitute in first. So we get r sine theta equals negative r cosine theta. Just like in my other piece, I'm going to move everything to one side. So you get r sine theta plus r cosine theta equals 0. What do they have in common? Well, they have an r, so let's factor that r times sine theta plus cosine theta equals 0. Now let's split this up. Okay, so that means r can equal 0 and sine theta plus cosine theta equals 0. Well, we just went over this in the other question, that this is a point, not an equation. So we need to disregard that. So what can we do here? Because now I no longer see an r. Well, let's continue. So I'm going to continue over here so I save some room. So I can move that cosine over. So sine theta equals negative cosine theta. Well, let's think about this. Where is sine theta equaling negative cosine theta? If you think about this, we've done this before. Remember, it's negative pi over 4 plus pi k. Because where is sine equal negative cosine? Well, that's in the second and fourth quadrant, right? So I don't want to make this simpler, I'm going to do the fourth quadrant because it's between negative pi over 2 and pi over 2, so that's easier to think about that. So it goes around and around and around. So really our equation to our graph of this y equals negative x is wherever theta equals negative pi over 4. Okay, so keep in mind that r can be whatever it wants to be now. Okay, r is whatever it wants to be, but theta has to be negative pi over 4 if we kept thinking about that 0 to pi over 2. Now, why is it that I'm only putting negative pi over 4? Well, if you remember with graphing polar coordinates, right? If I did negative pi over 4 and I was down in the fourth quadrant there, I could get to the second quadrant by saying a negative r, right? Because if I'm in the middle and I'm going to go on negative pi over 4, my positive r would keep me in the fourth quadrant, but my negative r would bring me in the second quadrant. So it is okay to say just theta equals negative pi over 4. Alright, one more practice with going from rectangular to polar. So I'm going to substitute in again, and I get r sine theta equals r cosine theta squared. So we have r sine theta equals r squared cosine squared theta. Well, let's think of this. We can divide by an r and we get sine theta equals r cosine squared. So remember, the whole idea was to get r by itself if there was an r. So let's divide both sides. I'm going to say r equals sine cosine squared theta. Now we're going to make this look better by having everything in the numerator. So we have to manipulate this and change this around. So I'm going to rewrite this as r equals sine theta over cosine theta. Well, what does that change into? Well, r equals sine over cosine is tangent theta, and 1 over cosine theta is secant theta. And we're done. Because we got our r equal. Alright, now we're going to go from polar to rectangular. Guys, to me this is a little bit easier, but I want you to keep in mind that there are different forms. So when you're doing your homework or your quiz, be careful how you're typing things in and what the answer could look like. You want to be able to manipulate a little bit more. So here we have r equals -3. That's great, but we need it to be in an equation, x and y's. So of course I'm going to deal with this r squared plus x squared plus y squared. I'm not going to deal with these two right now because we are still in trigonometry, and this one we don't even have a theta to be able to do this. Okay, so to make this a part look like r squared equals x squared plus y squared, I first need to square it. So I get r squared equals -3 squared, which we know in turn is r squared equals 9. Now if you look back, let's change our r squared. Our r squared equals x squared plus y squared equals 9. Now I want to prove something to you. So if we were to go back and we solved, square root of 9 could be 3 or -3. So we have to make sure that this would still create the same graph whether we had 3 or -3. If you remember though, r itself being -3 means we just go in the opposite direction. So x squared plus y squared is 9, right? Which is just a circle. Well, we could go with a positive r and get to our radius of our circle, or we could go a negative r, which would be going backwards, and then we still get our circle. So since I still get the same thing whether I'm going front or forwards, right? Because actually, if I thought about this, this would be a coordinate -3 theta plus pi. It would be the same exact circle. So this is a good answer. Okay. Alright, theta. What if we are given that theta is a 4 pi over 3? Well, for me, the easiest one to look at, because we do not have an r. If we had a theta and an r, I would want to use these guys. But I don't. I have a theta, so I'm going to use tangent. So let me use tangent theta equals y over x. So tangent 4 pi over 3 equals y over x. Well, tangent 4 pi over 3 is the square root of 3, so square root of 3 equals y over x. Let's solve for y to make this prettier. So that would give me y equals x square root of 3, and we are done. Right? We just want our equations in x and y's because we're going to rectangular. Alright, so r equals 1 minus cosine theta. Well, where did we get cosine theta? We get cosine from this x equals r cosine theta. So I'm actually going to solve for cosine and get it by itself. So I get cosine theta equals x over r. Now I'm going to substitute in. So I get r equals 1 minus x over r. The one thing I don't like is I don't like that r in the denominator. So I'm going to get that out by multiplying both sides by r. So we get r squared equals r minus x. Okay. Well, r squared is great because I already have an r squared. But how do I get my r? So let's keep in mind r squared equals x squared plus y squared. So how do I get r by itself? Well, r equals x squared plus y squared. All of that in the square root. Alright, so let's replace that. R squared is x squared plus y squared. And r is the square root of x squared plus y squared. And we have minus x. Now here's what I'm saying when we go backwards here, we have a lot of options. I could probably keep this as is, or I can move things around. So I could move it as in x squared plus y squared plus x equals the square root of x squared plus y squared. I could probably move some other stuff around too if I wanted. But really, guys, you just need to be comfortable with able to see what equations are equivalent. One thing I do want to point out that I see a lot of mistakes in is people want to break this up into x plus y. But you cannot take the square root of an answer when there's an addition in the middle here. Okay, now if this was, example, the square root of x plus y squared, now these two cancel. But when it's separated like this, it is not. You have to keep it as is. Alright, so do some practice on converting equations.